Right. Next one we have number 6. The diagram here we show a fly. The line XY represents the length of a wing. Yeah, right. The length of XY is 26 millimeters. Actual size of the wing is 4 millimeters. Okay, so what is the magnification? Okay, so yeah, the answer would be B. Alright, so when you come to calculating magnification, alright, magnification would be how many times bigger. That's the meaning of magnification. So if you take the original length, which is the actual size, okay, 4 mm times the magnification, you actually get the image. Okay, so this one is the actual one. Okay, so what you can do to find the magnification, image, which is 26 mm, divide by 4. Okay, and so you will get 6.5. Right? Now this is, by the way, you can use this formula when it comes to exam. Alright, the actual one, let me just make a slight correction. Okay, actual size times the magnification, you'll get the size of the image. The image is the one we measure with our own ruler. Yes. Right? So this one over here, this is the image. Isn't it? This is the image we would measure. This. So is the actual size or the length that is always given in the question. Now this one depends on the question. Okay. Sometimes in the question in exam, they might ask you to measure yourself with your own ruler lah. So you have to go in with your actual ruler and measure the length yourself. Alright, and from there, using the measurement that you got and maybe some other things, the question might give you magnification, they might give you the actual image, the actual size. So it depends on the question, but in the end, all these kind of questions, when it comes to calculating magnification, you can use this formula. Right? The magnification, once again, is just how many times bigger is the image. Alright. Then we can go on to the next one. Number 7, frog is an animal. Frog skin is permeable to oxygen and carbon dioxide. When a frog is swimming in pond water, in which directions will there be a net diffusion of oxygen and carbon dioxide? So everyone's saying A. Okay, from the frog into the water. Let's draw. Right, this is the frog into the water. Okay, so you say carbon dioxide is moving from frog into the water. Okay, yes, this is true. Okay, it is moving from the frog into the water. Why? Because the frog is respiring, it's breathing. So when it does respiration, it will produce carbon dioxide, which will leave the frog and go into the water through the skin, right? Because permeable to oxygen and carbon dioxide. Now, from the water into the frog, that will be oxygen, right? Because opposite law, and also the frog kind of needs oxygen for respiration. So as respiration is happening, oxygen will be like being consumed in the frog, whereas carbon dioxide is being produced. Alright, so the answer is A. A. Water contains oxygen. That is another reason for. Now the main one here is gas exchange. We're not really looking for the fact that water contains oxygen. I mean, water always contains oxygen, right? So in this case, we're actually focusing more like inside the frog. What is happening? Like inside the frog, there is respiration, right? Okay. In respiration, oxygen is being consumed. So inside the frog, in the frog itself, okay, there is a low concentration of oxygen because of respiration, and high concentration of carbon dioxide, right? So when there's a low concentration of oxygen in the frog, oxygen will move based on the gradient, right? From the water into the frog. Okay, and then carbon dioxide got opposite effect lah, because there is so much carbon dioxide in the frog, it has to come out into the water because the concentration of carbon dioxide in the frog is higher than outside the frog. Okay. All right. So fast I got answer. So number 8. Okay, so everyone's saying C. Which process only involves movement of water through the partially permeable membrane okay, of a cell. When there's a membrane, this is going to be osmosis. Alright. Okay, next one. Number 9. Okay, which statement about biological molecules is correct? Alright, so DNA contains bases A, C, G, and T. Yes, that is correct. Yes. Right? These are the little, the markers within the DNA. Alright. B, glycogen is made from glycerol molecules. This is just not correct. How to say? Glycogen and glycerol are different things. They are different things. For C, oils are made from amino acids and glucose. No, amino acids is protein, glucose is carbohydrate, oil is fat. Completely different things, right? And proteins are made from fatty acids. Once again, we're talking about different nutrients. Yeah, protein and fat. Okay. These things don't crisscross each other, right? Oil is okay. Next one. Okay, so someone says answer is the digestive effects of enzymes working in the human digestive system. Alright, so we have the protein and then enzyme at pH 1.5, temperature 37 degrees. This is body temperature. Okay, and it becomes amino acids. Okay, so what would reduce the rate of production of amino acids? Yes, by raising the pH to 7.5. This is around the neutral zone, slightly alkaline, whereas the enzyme was previously at 1.5, which is very acidic. So that means this protein most likely is in the stomach, or stomach protein, stomach acid in the stomach. Okay, so yeah, by raising the pH to 7.5, the enzyme will stop working. Alright. As for the rest of the answers that say A, removing amino acids as their form, then this won't affect the rate of production because in the end it's already been produced. If you remove it, there's no difference. Right? The enzyme will still keep on producing amino acids. As for B, increasing the amount of protein, actually that could actually make more amino acids. Alright, which variant? The code you mean, is it 0610 paper 2? Okay. Yeah, so let me continue. Increasing amount of protein will actually increase the production of amino acids. Okay. And raising temperature to 37.1 degrees Celsius. This one very funny lah. Increased by 0.1 degrees Celsius, which is so little. Right? Not enough. Right? Usually for enzymes, you have to increase the temperature 60 degrees, then you start to denature.